cloud platform, a project that we realized over the last 3 years. Maybe first a little bit about me. My name is Joos. I work at Ostschweizer, as already mentioned. I'm a master and a passionate gamer, a mountain biker, and here's the warning for all of you: I'm a programmer, I'm not really a designer, so this is going to be a little bit of a technical talk. There we go. All right, and so since you can already see me here and on the live stream, I thought you would rather enjoy a picture of my cat. All right, I'm going to talk a bit about, well, we already did that, how we got here, so what was our project, what our big problem was, what our solution to that problem is or looks like. A short demo, it will be a video, and at the end I'll tell you my conclusion to that. So, how did we get here? We were approached by a business partner about doing Exergames for stroke patients, specifically to use user-generated content to improve therapy success. The idea was to use pictures from like family members, grandkids especially, to improve the therapeutic success. We already heard yesterday a few times mentioned that involving family can be really helpful in that way. And the second part that our business partner wanted to do was he had a talk with a patient called Gerda, and she shared a vivid memory of cycling up the Gotthard mountain pass. And so he wanted to include that. This was the start of the project. So we had like everything ready, the clinics, the partners, and everything was ready. But then we had a different kind of problem, and that's why I have to do the next disclaimer here. I'm not really going to talk about the user-generated content part, but our big problem was developing Exergame is really hard, and without devices, so without home trainers, without heart rate sensors and stuff like that, it gets even harder. And if you're talking in a clinical environment, accessing certified devices can be basically impossible. Some of you may know these sensors can be very cheap, like $30, or they can rank up to something like $250,000 upwards. No developer or no game developer can put such device inside their studio. I think that should be obvious. So we thought about how can we solve that problem? How can we talk about these devices if we don't have them in our studio? We thought about how can we standardize this communication between the devices and their games. How do these devices connect to the games, and how is that data transferred? The solution that we came up with looks a little bit like this. We have a centralized server that each device in each game will connect to through through web standards like REST, WebSockets, and JSON. And that was one part. So we chose those standards because they are ubiquitous. Basically, any device that you can connect somehow to the internet can do that. And we defined 2 new interfaces to facilitate that communication. And these are those 2 interfaces. The first is the port. Ports are like connectors, where you can connect basically anything that fits into a port. You can connect it. I'll elaborate on that a little bit later. And the second part is the data part. So how is that data formatted, and how can you use it in your game? First, let's talk a bit about the ports. As just mentioned, a port defines on one side what a device can do, so its capabilities, And on the other side, what does a game need to play? So its requirements. For example, it needs a few buttons to be able to be controlled, and the device has like maybe if you think about a gamepad, an almost standardized gamepad controller, a button could be such a port. Each port defines a unique ID, both for the client, so for one device, and for the port itself, so that you can distinguish in between them. As mentioned, they communicate through WebSockets, and each device would implement a gateway, as we call them, or a driver. We settled on that solution because it allows us to basically put the gateway anywhere we want. We could, for example, hook up a home trainer to a laptop and have the gateway here, which connects then to the server. We could implement it directly on the device, maybe through an Arduino device or something like that. So it gives us the freedom to put these gateways basically anywhere that we see fit, or implement them anywhere we see fit. And yeah, so we can basically put them in any kind of device we want. The second part is our data classes. Now, this is based on a paper by Stuck. They had a paper called Classifying Input for Active Games, and they identified 6 different data classes. I write here 7. I'll elaborate on that in a short while. So they have different kind of data classes that they identified that says, well, these are all the types of inputs you can have for an Exergame. That is, those classes, a simple tap, that's a button on or off. You have axis, so you map that to a range from -1 to 1, with 0 being dead center. Point on a normalized rectangle that could be mapped to a touchscreen, something like that. A power, I don't think you can see the heart rate sensor quite as good, but still there. It could be, for example, a heart rate sensor or a cadence sensor, something like that. We have gestures. Gesture is a named event, basically. So when a tennis racket hits a ball, that could be a gesture. And a stance. So if anybody has ever played with Kinect, you know what that would look like. So you can take a representation of your skeleton, basically. Those are the 6 classes identified originally, and we added a 7th one, array, which can be used, for example, to model VR controllers. So you have a position and an orientation in a space. So I'll show a little bit of how on the process, so how would that work. And the devices, we have 2 here, a bike and a watch. They would connect to a server at any point in time. The game announces its requirements as well. And then we have the user. And the user now says, okay, I want to connect this device to this game in a certain way. I'll show that later. The server will send connection information to both the game and the device, and facilitates the data flow from the device to the game. You can do a little extension here where you can actually channel data from the game back to the device. If you have like a force feedback device, you could do it in the other direction as well. It doesn't impede that in any way. I'll give you a short example maybe with the port, since it can be a little bit hard to imagine. Let's have a typical home trainer. This home trainer can provide us with several things. For example, the cadence, so how fast the pedals are spinning, can be mapped to a power. The heart rate, which is measured by the handles, could also be mapped to a power. Shifting up and down, we have 2 buttons. You can map that to a tap, and on this special device you have a little bit of steering, so you can map that to an axis. Now we've broken down that device into its components, so we don't have to think about specific implementation, we just need to know what it can provide. Let's have an example game, flying bike game, for example. your target is to collect the yellow dots above, I think that's like Zurich actually. I'm sorry I couldn't change it to measure that any time. If you pedal harder, you ascend. If you pedal slower, you descend, and you have to steer through those rings I wrote here, but they're actually bubbles. And this game needs three things. It needs a power to measure how fast you're going. It needs a little bit of steering, and it needs one click for an interaction. So we map that again to power, axis, and tap. And now we can simply connect them. We can connect the cadence to power. We can connect the steering to the steering input, of course, and we can choose basically either the up or down button for the interactive part. The fun thing is, since this is all live, so all in real time, in the middle of the training you could say, okay, the bike isn't really working anymore, so you can switch it in real time to another port. Right. Okay, so here is a little demo. It's a game that we made to demonstrate the demo effect, apparently. Yeah. I'll post a link to the video later. It's on YouTube, so you can watch it afterwards, and it will show a little bit in live what kind of devices and what kind of games we made for that project. I'm very sorry that the video didn't work out. In our conclusions, what we find is that with this approach, you can really simplify the development of Exergame, since it allows you to think about the capabilities and the requirements of the game. You're not thinking about, okay, which API and SDK do I need to connect that. You just know I can, as long as I implement that interface, any game works with any device that will support our interface. Trying out new configurations is also really quick. For example, we had with the kayak game that I showed you, just steer left and right, and we could have two buttons. So we tried it first just with a single player, and then we just gave both buttons to different players, and suddenly we had a multiplayer game without doing any recoding or stuff like that. It was really fun to watch them light up like that. And adding new devices does not require you to change your game. So as long as both the device and the game support the interface, you can connect anything, even if it's a new device that was created years afterwards. And lastly, the games can be created separately from the device. So you can develop the whole game inside your studio. The device manufacturer provides you with what kind of ports the device supports, and you just code against that. And you don't have to worry about how the device exactly works. perspective. So what we need to do now, or what we are trying to do, we need to facilitate the access to that interface. For anyone interested, documentation to our interface is on the QR code on the left, and we already started to get some additional funding to try to find out how much we can push that that approach from the canton of Graubünden. So I'm from the very east, if anyone didn't notice yet. And yeah, we need support from more game developers, and we need support from device manufacturers, and that's what we will try in the next few months and years. So, thank you very much. I hope you enjoyed the talk, even though it was a little bit technical. And yeah, special thanks to Stefan and Julian for the organization of the whole conference. Thank you very much.
Thank you. Any questions?
If I understood correctly, this is a very smart interface between device and program, correct?
A smart interface?
Yeah.
Yes. Well, it can be looked at it like that, yes.
And very smart, very useful. The question is, have you experienced many trouble in terms of protocols? A lot of devices come from China, Korea, Japan, and so, and also sensitivity on the parameter of the
yes.
device itself.
Yeah. The good thing is, since we were most in control of doing the development of the gateways, we had a lot of control over the sensitivity and stuff like that. But it also, maybe a question that is popping up is also, okay, is WebSocket even fast enough for something like that? But like the sensors, for example, from my watch, they have a resolution of like 2 seconds. So I think we're fast enough there. And yeah, so that's something you have to take into account anyway, I think, when you're developing your Exergame. And what I experienced, that you shouldn't really make an Exergame that requires really rapid movements, because if somebody gets off balance in some way, they could hurt themselves. So really try to have controlled movements like that. So no, we didn't really experience a lot of problems with the sensor data, stuff like that, but it's something that you have to keep in mind.
Just one more curiosity about that. Do you have a protocol kind of self-calibrating in the very first 2 seconds when you connect the device, kind of self-calibration property?
That would need to be implemented on the gateway, so on the program that connects to the server.
Okay.
Yes. So we can do that. Yes.
Thank you.
We have time for just one more question. So maybe that question would be, could you elaborate really live about the demo you were going to show us? Or what was about to be screened?
Yes, I can. Well, it's like explaining a joke. You'll kill it. But yeah, I can quickly tell you what's in there. It's actually, you see the link down here. If you copy it, or if you type that link into your browser, you will see it. And basically what we show is how you connect your devices and your games. We have like a node-based way to do that. You could also do an automatic way to connect device and game. And we also show a few different devices that we implemented for our games. So short list is like, as I said, smartwatches or and plus watches. We have cadence sensors from bikes. We have the dance pad from Dance Dance Revolution. We have the, I don't know if anybody remembers that, but the Donkey Kong bongos from way back in the GameCube days. Joysticks, yeah. So we have a lot of different devices, and it's really easy to connect them all together and do fun stuff with it.
Thank you very much.
Thank you.
Thank you, Patrick. So, a round of applause for him.